Today I've got for you a simple UART communication example with Arduino Due and a UART-USB converter. Writing is done in polling mode and reading is done with interrupts. So the example uses a baud rate of 9600. So let's open up the port and we get a X and a additional new line. So if we see the hexadecimal, you can see the X and this is a new line charter. Okay, and for testing the receiving, we just simply send letter A, so it changes to this letter, and again X, we are back at sending the letter X. Okay, so now for the code. So this example uses ASF. So if we go right here, we can see that if we have our project selected, we can add some libraries to it. So I added the UART and also delay routines. There are a few quick functions to create a polling mode delay. Okay, so we've got our main file and what to start with. So we have to enable the clock for the peripheral, so for the POE, so like this, and we also have to assign the peripheral that it is a, and we also have to assign the pins to the correct peripheral. So the question is, how do you know which one it is? So we will have to take a look at the datasheet. Okay, so we got here our datasheet, so let's search for UART. Right here. We've got the description for the UART peripheral, and right here we got which pins are connected to this peripheral and which one it is. So peripheral A controls those pins, so we have to set it in here that we want it for those two pins, like so. Next on we will go into setting up the UART. So we can take a look at UART.c, which can be found right here. So as we go into this file, we got here a description how to enable everything. So we will use the UART init function. So it needs a pointer to the UART instance, so this is the address where the peripheral resides. And next one, we got a configuration structure here, so we can just simply take a look what it is. So we got here the main clock, which is in the microcontroller. So this will be the 84 megahertz, which we set up right here. And next on, we got the baud rate that we want to set up, and also mode. So for example, if you want to use a optical transfer, you can set it right here. So we need to implement this in our main function. So I set up here a UART setup, created the structure here, and it is being initialized right here. The UART mode is the default one, so it is 8 bits of transfer, no parity, 1 stop bit, so the default one. and I also use the default baud rate. Next on we can initialize the UART. So we got a define here, which is a pointer to the memory where the UART peripheral is, and we also would like to use interrupts. So we got here a function to enable the interrupts. It is a really basic function that writes to a address in the memory of the UART peripheral, and it is not being really described here what it is. So again, we have to check in the datasheet. So we are searching for the registry entry for the interrupt enable register. So this one. Let's scroll down. And right here we got what we want to write into the register. So the first bit is the RX ready bit, the interrupt here for it, for the text, and so on. In this case we will use only the RX ready interrupt. So as soon as we get something in the buffer, so we send data from the computer, we will get this interrupt going on. So to our example, I set the first bit in the interrupt, and next on there is to remember that if you set up a interrupt here in the M3 core, you have to also enable it using the nested vector interrupt controller. So first of all, set up the priority, and next on enable it. Okay, after this we also have to enable the receiving and transmitting. As we got this set up, we have to set up a function for receiving in our case. So there's a file here, exceptions.c, and if we go right here, we can see that we got the complete list of the interrupts for the M3 core. So we are looking for the UART handler, the default one, so we got it right here, and it is being declared as a weak alias to the dynamic handler, so it does nothing by default. And with this attribute we can skip exporting functions to this file and just simply declare another one, so the UART handler in our main function. So we got it doubled right here. So if we have this function, so going back to the exceptions.c, it will be overwritten. Instead of this, we will use this. Okay, and right here we only have the interrupt for receiving, so we are sure that we can read something. So we read 1 byte of data from UART and save it to our variable right here. And we compare it. If we got a received in ASCII, we set a flag, which is here, to 1, and in the main loop we will simply switch the content that we are sending from X to A. So simple as that. Okay, so let's take a look again at the data visualizer. So we are receiving X, sending A, and the communication works. Hope you find it useful in your projects, and see you in the next one.